Okay, everybody, welcome to day 4. We are going to switch out of adding and subtracting fractions and start working with multiplying these things. So without further ado, let's just get into it. But before we actually multiply the fractions, let's begin with remembering how to simplify fractions. I know you know how to simplify fractions with numbers. I'm just reminding you, is it legal to do like an x squared cancel like that? And of course, the answer is no. You can cancel things if they are common factors. So there we go with the F word. We begin with factoring absolutely everything. So let's go ahead and factor our numerator. We'll do the 2 parentheses because we see in this particular numerator right here, there are no common factors. So we're going to go straight to x and x. I believe a -3 and a +1 will work. And then we go to the denominator, and in this denominator, we begin with taking out a common factor of 4. What's left in parentheses then is x squared plus 5x plus 4, which of course that can be factored more. So now I'm going to switch ink colors again and go and copy the top 2 factors, x minus 3x plus 1. Let's keep the denominator factor of 4 because you worked hard to get it, so don't just drop it. And then you can do the 2 binomial factors, x and x. The numbers that multiply to make 4, that add to make 5 would be plus 4 plus 1. And then you can take a look at your fully factored. It's fully factored because there's no more common factors and there's no more x squareds to break down. And you can take a common factor of x plus 1 on the top and the bottom and cancel. So your final fraction answer will be x minus 3 over 4 parentheses x plus 4. You don't need to distribute the denominator. You can just leave it listed in, I'll say factored form. But of course, the restrictions, you have to tell me that x cannot take on the value of course, -4, because that was from our answer, as well as -1, because that was canceled. And then there wasn't anything else that we canceled along the way, so those are our only 2 restrictions. And we're ready to move on to the next problem. But remember, you're always going to look first to see if you can do a greatest common factor. So in this numerator, we definitely have a GCF. In fact, it's going to be 3x squared. What's left in parentheses then is just going to be a simple x plus 2. And then in the denominator, we also have a GCF, and that one's going to be x squared. What's left in parentheses there will be x squared minus 3x minus 10. And I think you guys can see that that x squared minus 3x minus 10 is factorable. So I'm just going to go ahead and new ink color and copy the numerator, 3x squared, parentheses x plus 2. In the denominator, we'll have our original x squared from a common factor, and then we'll go straight into the 2 binomial factors. We'll have x and x. And what multiplies to make -10 and adds to make -3 would be a -5 and then a +2. Now, as far as the factors that are cancelable are concerned, remember this 3 is getting timesed with x squared, which is getting timesed with the factor of x plus 2. And then in the denominator, that x squared is getting timesed with the x minus 5, which is getting timesed by the x plus 2. So the factors are x plus 2 as cancelers, and the x squared as cancelers, which gives you a final answer of only 3 left over on the top and a denominator of x minus 5. So it's super important to factor slowly and carefully and don't make any crazy mistakes. So the restrictions then is course 5, because that's left over in the denominator. Then you got to go back and look at the factors that you canceled. And it looks like we had a factor of x plus 2, which gives you a restriction of -2, and x squared. And x squared gives you a restriction of 0. Now, since it's x squared, remember back in December, we said that that's x times x, so like multiplicity of 2. We don't need that when you're listing exclusions. You can just be done. So that means if this is how we reduce fractions, let's talk about how we multiply fractions. And I've got really like super good news, because it's really nothing different than what we just did. In fact, all you're going to do is copy the numerator, x plus 2, times the next numerator, x plus 4. In the world of fractions, if you had something lame, like 1 over 2 times by 3 over 4, you just times the top numbers together and times the bottom numbers together, and then that gives you your answer. So I'm showing you up in the corner here just a simple 1 over 2 times 3 over 4, but that's what we're going to do with our x's and these other factors. However, look carefully at this first left denominator. There's a common factor of 3. So factor that out, and what's left is x plus 4. And then that's getting timesed by, and I'm underlining it, you got x squared minus 4, which is super convenient because that's one of those difference of squares problems. It does not have i's because it's a minus sign, so you're just going to look at an x and an x, a plus and a minus, and then the square root of 4 gives you a 2 and a 2. And then look for cancelers. I got an x plus 4 and an x plus 4 and an x plus 2 and an x plus 2, which is awesome. And I'm doing this example because sometimes I've seen people make the mistake. Technically, when you cancel, you're dividing. Like, for example, I'll just circle these so everybody can see them. When you're dividing those, something divided by itself equals 1. So technically, when we canceled the x plus 2, and the x plus 4 out of the numerator, what's left is a 1 on top. Sometimes people accidentally put 0, and so that's what I want to make sure we avoid by doing this particular problem. Go ahead and copy your final answer and then give me your restrictions. X cannot take on the value of 2, obviously, since that's still in the denominator. Go back and look at every step of the denominator that you had and give me the other cancelers of negative 4 and negative 2. If you wanted to make your 2 to just be plus or minus 2, that's A-okay by me. And then one more, and then this is our last one. So this is a super short set of notes, but this is a doozy. Check this out. Holy dang. Let's go ahead and start factoring. Always GCF first, and then the normal 2 parentheses, the 2 binomial factors. So in this first numerator, I'm looking at a common factor of 2x. Once you take that out, what's left in parentheses would be a 5x plus 1. I'm going to go straight across to the next numerator and put a times dot. And the next numerator doesn't have a common factor. And so this is the one where you're like, ugh. Okay, so remember, you do the 2 parentheses. I'm just going to show a quick guess and check. So you got 2 numbers that multiply to make 3. I'm going to go ahead and list 3x with x. And then you need 2 numbers that multiply together to make 2. So that means we're looking at 1 and 2 or 2 and 1. You have to arrange them so when you loop check, you end up getting a middle term of negative 1x. So if you were to put a 1 there and a 2 there, that would be a great big, it doesn't work, because your outer loop would make 6x, and there's no way you're going to get this negative 1x in the middle to work. So I'm going to back that off, go away, go away, go away. And instead of 1 and then 2, we're going to do 2 and then 1. And if I loop check, I get a 2x for the inner loop and a 3x for the outer loop, which means since I'm trying to get a negative 1x in the middle, if I do a negative there and a positive there, you can complete your loop check and see that that makes 2x and negative 3x, and those add together to make negative 1x. So now I'm going to erase my loops because that piece is done. And now we give ourselves the denominator and factor the denominator pieces. So the first part in the denominator has a common factor of 6x. What's left in parentheses would be x plus 1 times the second denominator does not have a common factor, but it is one of those. So when I say one of those, let's do it. Parentheses, parentheses, we're going to guess and check and be super efficient. Skip that x business and that box method and that AC stuff. The only numbers that times together to make 5 are 5 and 1. So give yourself a 5x and an x. The only numbers that multiply to make 1, oh my gosh, hooray, hooray, is 1 and 1. You just got to figure out where you're going to put your plus and your minus. So if you do a plus here, that gives you an inner loop of positive 1x. And if you do your minus to the second one, then that gives you an outer loop of negative 5x. Those add together to make negative 4x. And now I'm going to erase my loop check work so that way we can continue and finish this fraction problem by canceling any factors on the top and the bottom that are identical. Looks like I got a 5x plus 1 that zap and an x minus 1 that zaps. And keep going, because why stop the fun now? You got x's that zap as well as 2 goes into 2 once and 2 goes into 6 3 times. Wowzers. So our final answer on the top, we've got the 1 times the 3x plus 2, which is a 3x plus 2 on top. And in the denominator, all we have left is a 3 and then an x plus 1. Whew. So we got serious cancellation going on here. Give me the restrictions. X cannot take on the value of -1. That's the one from my answer. And then you look at anything that canceled. We had a positive 1 that canceled, so I'm going to go ahead and make this a plus or minus 1. We had a 5x plus 1, so that's a -1/5. And we had the x that canceled, which gives you a 0. And those are our restrictions. And that is the end of the story. You can see I'm scrolling. We're at the end. And that's all I've got for you. Go ahead and roll into the homework assignment, and I'll catch you next time. Bye.